All of these area formulas can be derived from the area formula of a rectangle. Yep, even the area formula of a circle. Let's see how. First, the area formula of a rectangle is base times height, because that's how many square units can fit inside the shape. Now, how does a parallelogram relate to a rectangle? Well, if we cut off this triangle and we put it on the other side, we get a rectangle. And we know a rectangle's area formula is base times height, so the area formula of a parallelogram is the same thing. Now, with a triangle, we can see it as half of a rectangle as we see over here. These two triangles are congruent to each other, these two triangles are congruent to each other, so it's just half of the area of this rectangle. Now, it's important to note that base and height are always perpendicular to each other. So we see that the area formula of a triangle is half base times height, because once again, it's half of a rectangle. But what about a trapezoid? What we're going to do is we're going to copy, rotate 180 degrees, and paste it on the side, so we get a parallelogram. And we know the area formula of a parallelogram. It's base times height, base being base 1 plus base 2 times the height. But we only want one of these shapes. We don't want both of these, so we cut that in half. And with the kite, it's kind of like a triangle in that it's half of a rectangle, as we see over here. Notice, we don't care about the side lengths of the kite. Instead, we care about the diagonals of the kite, because that gives us our base and our height of our rectangle. So the area formula of a kite is half of this rectangle, which is half diagonal 1 times diagonal 2. Now, let's talk about regular hexagons, or regular n-gons in general. Regular meaning all the sides and all the angles are the same. So with the regular hexagon, we are going to cut it up into triangles like this, let them unravel, grab half of those triangles, and put them upside down in the empty spaces of the other triangles. Because when we do that, we get a parallelogram. Now we know the area formula of a triangle is base times height. So what's the base and height here? Well, the base is half of the perimeter of the regular hexagon, because when we let these triangles unravel, we get the whole perimeter over here, but we grabbed half of the triangles to put them upside down. So what's remaining is the other half of the perimeter. Now, the height of this parallelogram is the height of each of these triangles, which we call the apothem. The apothem goes from the center of the shape straight down perpendicular to a side. So the area formula of a regular hexagon, or regular n-gons in general, is the area of this parallelogram, which is half perimeter times apothem. Now, believe it or not, we could do basically the same thing with a circle. Cut it up into wedges, let the wedges unravel, grab half of them, and put them upside down in the empty spaces of the others. Now, I know that this doesn't look like a parallelogram, but what if instead of 8 wedges, we had 1,000 wedges, 1,000,000 wedges, 1,000,000,000 wedges? The more wedges we have, this is going to tend to a rectangle. And we know a rectangle's area formula is base times height. Our base being half of the circumference, so half of 2 pi r, which is pi r, and our height is the radius. So the area formula of a circle is pi r times r, which is pi r squared. So there you have it. All of these area formulas can relate back to the area formula of a rectangle.